Good morning for you in Canada, and good afternoon, sorry, in Europe. My name is Petúr, Helgi Einarsson. This talk I have with me Riedel as part of the European side, and Tristan, Glatard, Valérie, Hayot, and Natacha, Beck from the Canadian side. I'm a PhD student at the University of Iceland, and I got this amazing opportunity to be a part of this project. Well, in this introduction, I'm going to talk about what we plan to do in HIBALL and how we plan to have the architecture to enable a joint infrastructure between CSSE and CBRAIN in Canada. This should facilitate joint workflows and data access between the two entities. So what's this architecture about? The main goal here is to have a joint infrastructure so that the modular supercomputer at CSSE can be connected to CBRAIN. And in order to achieve this, we need to implement two steps. Step one, this is the workflows. I mean, there are different workflows being used. For example, scalable deep learning methods, the HIBALL framework. Also at CSSE, they use innovative GPU interconnect. This enhances data movement and access to the storage drives and network adapters. So you can read directly to GPU memory and from GPU memory and write to it as well directly. But how can we exchange pipelines? We can explore the boutique systems that is widely used in CBRAINs. There's also some uses in at CSSE. Well, boutiques can be used to import and manage deployments of pipelines at scale, and it uses container engines like Docker and Singularity for deploying tools across platforms without installation. So that is all about what containers are, that you can ship them between platforms without installing additional software. Then step two is the data access. We want to exploit hierarchical memory architecture for the datasets. This means how can we utilize the different components in the system to maximize the performance. This is still in research, but I mean, data storage access is, for example, slow, and data must flow from the storage system to the CPUs and then to the GPUs to do the computations. And this is also what we want to do. How do we exchange and synchronize data between the infrastructures in an optimal way? And there's some need to do some optimizations on the input-output aspect. On the bottom right, we see the dual system, the Supercomputing Center. It's modular, so that means that different modules and components have different responsibilities. So the module one, as you can see here, this is the CPU cluster. It has many CPUs, which it can do, things that we normally do. Then module two, this is the booster module. It has a lot of interconnected GPUs for some parallel processing and can be used for deep learning. It's often used there to speed up. Module three is a data analytics module. It has huge memory, which is needed to do some data crunching. And then here also we have a neuromorphic system, which is, it mimics some neurobiological architectures. You can change over time. And then we have a quantum module and a multi-tier storage system for storing the data. The initial work is having to draft an architecture of joint infrastructure between JSC and CBRAIN and test it. And this is what we have here. It's a pretty complicated picture. But if you look here at the bottom layer, we have here the CBRAIN supercomputing resources, and here we have the computers at JSC. So these computers, they use a scheduling system that's called Slurm that schedules the programs and who can execute what at what time. So it doesn't get overcrowded and people get access. And for this scheduler, we need to specify which software you're going to use. Are you going to use some biology software? Are you going to use Keras or TensorFlow that's used for machine learning, etc.? And this is the same across the systems. But in order to use these systems, you have to have, well, you have to be authenticated, and you also have rights to be there. So this is different between CBRAIN and JSC, how it's implemented. At CBRAIN, they have group accounts, which means that you can't really identify who is who. You can only say what part of what group they're part of. So you can't really say who it is. But whereas in JSC, you have federated identity. So you can see exactly who is doing what on the system. And this is still open work, like if we're gonna, how we're gonna implement this exactly on both sides. And the reason I'm going through this graph here is that every node here should be able to traverse to here. So a person sitting in Canada should be able to use, for example, the Jülich system, the JSC storage, etc. And the same with the people sitting in Europe. They might want to use some data from CBRAIN. This brings me to the next layer, the data access layer. CBRAIN has some storage nodes to store some data, and they widely use DataLad to access or manage the data. We're gonna go into that deeper today with Tristan and Maurice. Whereas in JSC, we have another storage here, and we haven't used much DataLad, but the INM1 BigBrain data is being managed that way. And Maurice will talk to you about that more. But how do we connect things here? That's still an open problem or work. SCP, the secure copy. It's secure, but it's not good for big data. The other hand, grid FTP, that's pretty good for big data, but it's not as secure as we would like it maybe. So this is still a thing we need to work on. If we move a layer up, you can see here the workflows and pipelines. So CBRAIN here, we have some containers and boutique containers, respectively. The boutique containers, they use some JSON resources to describe what you're trying to do with the data and what data. On the right hand side here, we have SnakeMake, which is widely used in JSE. This is just a pipeline tool with descriptors in Python. And this is used a lot here, but we also want to offer the boutique pipeline or workflow here. So if a person here in Europe wants to use their terminal instead of the CBRAIN portal to use a boutique container, there's still some exploration that has to be done there. So we're almost at the top. Here we have the infrastructure, the Helmholtz, the JSE infrastructure under Helmholtz has been a little bit correlated with the Phoenix and the eBrain's infrastructure and being used to compute some and they have some resources that is in JSE. And this brings us here to the top where the user sits, and that is you. So basically what we want is that you can access the data and the systems, and no matter if you're a console user or a portal user. So just to summarize things up, the containers, we have some initial setup that we tested from Canada. We had a Docker image that ran on the Jülich system and used data there, and that was no big problem. And yeah, so yeah, the boutiques and SnakeMakes that should be available to everyone, hopefully at the JSC site. So that's it for me. So I want to give the podium to Morris.